All right, I realized when I was uploading the other videos that my numbering is off. This says problem 19, but I think it's problem, I don't know, we did 14 twice, so 11, 12, 13, 14, 15, 16. This is technically problem 17, but I'm going to keep it labeled as such. So anyway, list the following about the given polynomial, then sketch. The degree is 4. That's the highest value in the exponent. Leading coefficient is the number that is multiplied in front of that highest term, so that's -1. Possible number of terms is the degree minus 1, so 3. Possible number of real zeros. Because this is x to the 4th, we could have all 4 real zeros. This question too, if I asked you for the possible number of imaginary zeros, we could also have 4 because imaginaries travel in pairs. So it's just thinking about how those imaginary roots come. End behavior, well, since this is a even degree with a negative coefficient, even degree with a negative coefficient. Even means our ends are in balance with each other. Because of the negative, they're going to be both pointing down. So as x goes to positive infinity, y is going down to negative infinity. And as x goes to negative infinity, y is also going down to negative infinity. So I know that my ends should look like this. My roots and x-intercepts show work to find roots here. So I'm going to set everything equal to 0. I'm going to factor out my greatest common factor, which is a negative x squared. And I'm going to be left with x squared minus 9. Well, that means that negative x squared equals 0. So x equals 0, but that's going to be a double root. So 0, 0 is a double root, which has a multiplicity of 2. And then this one is going to give me x squared minus 9 equals 0, which means x equals plus or minus 3. Each of those is an individual root or a single multiplicity. Single root times 1. So I want to plot them, but I'll pass through those points as opposed to bouncing at the 0. So again, our roots are 0, 0, 3, 0, and negative 3, 0. So now I got to think about how to connect the dots. So I'm supposed to start here, pass through the single root, bounce on the double root, pass through a single root. And there's a good sketch. You also can use your calculator to help you with the sketch. Don't forget that. All right, number 20, which is really like number 18. I don't really know what's happening. Find the pattern, explicit rule, so A sub n, for the following sequences. If you can't find the rule mathematically, at least explain it in terms of a pattern. At this point, right now, before test number 5, we've just introduced these concepts, so I'm more concerned about you being able to find and understand the pattern than being able to write the explicit rule. So, to look at our first one, we know we have a fraction bar. That's great. Across the top, how do I go from 3 to 9, 9 to 27, 27 to 81? I'm multiplying by 3 each time. Then on the bottom, 1 to 4 to 9 to 16, there's that pattern of plus 3, plus 5, plus 7. So I know I'm going to have something with squares. Well, now putting this together, A sub n, the bottom, if I plug in 1, I get 1. If I plug in 2, I get 4. If I plug 3, I get 9. If I plug in 4, I get 16. So the bottom is just n squared. That stays as it is. How do we talk about repeated multiplication? Well, repeated multiplication turns into an exponential because this is 3 times 3 times 3 times 3 over and over and over. The one thing you want to check for is just to make sure that what was your term previous, right here. I shouldn't actually put a 0. I should just put like this. Well, the number that I would have had to start with this whole thing would have been a times 1. So you can write that if you want to, but you don't have to. All right, next one. Pattern is alternating. This is positive, negative, positive, negative, positive, negative, I would assume for the next. And it looks like we are adding 5 each time. So what I can do here is I can think about those two things as separate parts of the pattern. A sub n, to deal with the -1, the alternating, if you remember from the first day, negative 1, I need to raise it to either the nth, which would put negatives in the even spots, or the n minus 1, or the n plus 1. All of those things work. So you want to raise it to the n if you want to have your positive ones be, your even ones be positive. N minus 1 if you want your odd ones to be positive. And plus 1 is also a way to get your odd ones to be positive, okay? So in our case, when I sub in 1, the first spot, 1 minus 1 is 0, negative 1 to the 0 is 1, so that creates a positive. When I plug in 2 from my second spot, 2 minus 1 is 1, negative 1 to the first is negative, so that takes care of that negative, etc. Well, now we have to figure out the next part, which was the plus 5 plus 5 plus 5. Repeated addition turns into multiplication. So 5n is going to take care of that part of the pattern. The last thing then would be to consider what was your initial spot. When n is equal to 0, what's here? Well, that's 0, so I don't need a plus 0 or any sort of y-intercept when we think about lines written over there. Again, for this test and this purpose, we would like to be able to explain the pattern, at least describe in words what's going on. 21, simplify. So remember the trick with factorials is you want to start with the highest number. So out of 4, 7, and 9, 9 is my highest factorial. So I'll start writing that out until I get to a place that will cancel. So I still had 4 factorial and 7 factorial. So the reason I stopped at 7 factorial is that these will go away. So I get 4 factorial over 72, which is 4 times 3 times 2 times 1 over 72. 4 times 2 is 8. 8 out of 72 is 9. I end up with 3/9, which is ultimately 1/3. You can get that on your calculator if that's easier for you. Next one, same thing. I want to start with the bigger factorial. Well, what's bigger? N or n lowered by 2? N is the bigger one. So I'm going to start listing out my factorial. N times the number 1 below n times the number 1 below that, which would be n minus 2. And I'm going to stop there because my factorials are a match. And I end up with n times n minus 1. This would be a perfectly okay answer. You could also write it as, well, that's the same thing, Schwartz. You could also write it as n squared minus n. Either one of these would be acceptable. Again, a reminder, the definition of a factorial is that you start with the number itself times the number lowered by 1 times that number lowered by 1 times that number lowered by 1, right? Over and over and over. Last one. Find the 10th term of the sequence whose nth term is a sub n. Well, if a sub n is to n and n, then I want to find a sub 10, which means that everywhere I see an n, I'm going to replace that n with a number 10. So let's clean that up. 2 times 10 is 20, plus 1 is 21. 5 times 3 times 10 minus 1, well, 10 minus 1 is 9. 3 times 9 is 27. 27 plus 5 is 32. And that's your final answer. All right, remember, 11 is the newest unit, so you've got videos there that you can watch. But a lot of this test will focus on unit 10 because that's the most recent unit with some other stuff spiraled back. If it wasn't on this review, it cannot show up on your test.